Hello, everyone, and welcome to the Enterprise Data Summit 2023. I am very excited to talk to you guys today about how T-Mobile US implemented data observability through platform optimization journey. My name is Vikas Ranjan. I'm a senior manager of a data analytics team in the network strategy and evolution department in T-Mobile. I have almost 19 years of experience, and pretty much all my experience has been in data space. In my most recent role, I have been leading and managing a data analytics team responsible for end-to-end analytics of a hyperscale data analytics ecosystem that is hybrid in nature. During my non-working hours, I love watching Seahawks games. I'm a big Seahawks fan, and I'd love to spend time with my 10-year son talking about the world economics, history, and politics of all the different countries. Before we delve into data observability, I have been fascinated by the innovation that has happened through various industrial revolutions over the last 3 centuries. It's pretty amazing and interesting to see how it took mankind almost 120 years to go from a steam power engine in 1780 to electricity in 1900s, and how it has turbocharged the pace of innovation between Industrial 3.0 with the advent of computers to the IoT in less than 30 years. It has been a fascinating, and a fast-paced innovation. And I don't think we are done yet. I think the Industrial Revolution 5.0 has actually accelerated the pace of innovation by what we call as a data-driven transformation through digital journey. I think it must not be wrong to say that Industrial Revolution 5.0 is nothing but delivering in value, doing new stuff, bringing new innovation in the space of data. Well, with having said that, we as in telcos have also seen a paradigm shift across the globe. Telcos are no longer a traditional mobile service providers or communication service providers. Telcos are now essentially seeing an exponential growth of data. There are around 5+ billion mobile users globally, and in the next 2 or 3 years, there will be around 40 billion devices connecting on the telco networks across the globe. We are also seeing there are new areas of businesses coming across the telcos with the ways to monetize the 5G, with the ways to bring in new services in the mobile computing, with the hyperscalers bringing in opportunities for telcos to build private network, edge computing. The opportunities are humongous, and the art of possibilities are super fueled by innovation in the artificial intelligence, from predicting the outage on the network to essentially leveraging the power of ChatGPT and generative AI to do self-service, as well as making changes on the network through automation by zero-touch operations. I think we can go on and on and on in the space of what we are seeing telcos as evolving. In a nutshell, I think we are evolving more from a traditional telco to more of a tech organization. With that, we actually kind of started building analytics platform as a part of the network engineering organization back in 2015. Before that, the analytics to us was a traditional data warehouse running on Attendees, and essentially we were processing at that time a massive scale of data, which was around 10 terabytes of call detail records. The first foray of us moving into the big data space was with the advent of Hadoop coming in early 2010s. And we started our journey of modernizing our platforms from a data warehouse to Hadoop in 2015. I think the journey was great. we saw tremendous value with tremendous benefits. We could really bring in a lot more variety of data. And we saw within no time, within less than 4 years, the Hadoop platform was no longer supporting all our business needs. We were not able to deliver all the insights, the value which we were delivering in the beginning. And that is where we saw the opportunity for us to modernize and expand our data estate with the bringing in the cloud capabilities. At the same time, our data was growing exponentially. We also were in the middle of perhaps the biggest telco merger globally with the integration or the merger with the Sprint. And in no time, we saw our data grew from 10 terabytes per day to around 300 terabytes per day. So we saw super exponential explosion of data on our data platform with the combined company. At the same time, T-Mobile launched many and exciting new services. We launched home internet, which is essentially one of the biggest Un-carrier we have launched in the recent years. And then with that, we see our customers using a lot more data traffic on our network than they were traditionally doing before. And then we could not really run our platforms very efficiently just on the Hadoop and cloud. And we started foray into the space of open source by bringing more cost-efficient, performant, auto-scalable solutions by running custom solutions on open source. At the same time, this has been a fascinating growth of data we saw in less than 2 years, from a 300 terabytes per day to 500 terabytes per day. And in this ecosystem, I think all the data teams, all the enterprises are now leveraging the best of the best by running a truly hybrid solution, a truly multi-cloud solution. With the journey we took with the Hadoop and then with the cloud, with the open source, we decided to bring in new capabilities of AI and ML. We decided to bring in new capabilities of a cloud-sized data warehouses by implementing a Snowflake environment. And we are continuing, as we continue to see exponential growth of data. As of today, we are processing around 700 plus terabytes of data from a different network logs on a daily basis, solving a lot of different business problems. I think they always say more success is always equal to more challenges. Although we have been pretty successful in our journey with a truly hyperscale hybrid data estate, we have also seen a lot more complexity in our data environments than it used to be before. We are processing, curating, and transforming various kind of different network logs, all coming under different file formats, structured, semi-structured, unstructured, data coming from IoT devices throughout the day. I spoke about a humongous data explosion in our platforms. We are processing around 100 plus terabytes of data per day with the trillions of events throughout the day. With the advent of cloud, I think the cost of running the platforms has also become a lot more challenging than what it used to be on the on-prem, where you could buy capacity upfront and you don't have to worry about the unknown cost. And the goods of cloud are also can be the challenges with the cloud, where you can bring in new services, but essentially the new services also bringing some unknowns and particularly in the cost. As I was talking about the shift of the telcos with the things to do with the multi-cloud, with the edge, with the private network, and the enterprises are looking at solving the problems as they happen. So it is more about time is the most critical currency now. We want to solve the business problems as the data is appearing. So we need the insights at fingertips. We need the insights now. So there has been a lot more demand and increase in the real-time use cases, in the real-time capabilities of this data. I think it would be safe to say that data is as good as, the value of data is as good as the quality of data. If your data is not good, you're going to make some really bad business decisions. So the reliability of data, the complexity of data has become even more important. and more challenging now than ever before. In order for us to do all of this, connecting the dots together, bringing all this complex data sets, complex ecosystem of tools and technologies, I think the skills of the teams has been becoming extremely big challenges. This is what we have seen in an organization where we have to constantly upskill our teams. We have to make sure that our traditional data engineers are not just data engineers, they have a strong knowledge of data engineering, software engineering. We have some very strong power users and data engineers. How do we kind of bring in the new capabilities in terms of machine learning? How do we bring our people with the domain knowledge and kind of bring the best of the best all together by constantly upskilling our teams? With all those things, what we have seen is this new interesting word called data observability. Data observability has been a term that has been coined by Excel Data, who are pioneers in this space, and Gartner has recognized this as one of the emerging trend now. Essentially, data observability is looking at your business and data process telemetry as the 4 different dimensions. The first dimension is all about running your data pipelines and understanding the patterns of your pipelines, identify the issue with your pipelines, the transformation rules, how you bring the data from point A to point B to point C, what is happening at each step of your, I would say, data train, right? At the same time, as you are processing this data, coming at the different latency, coming at the different frequency, coming at the different volume, I think, and especially when you're doing these things in cloud, I think it's extremely important to understand how do we run this in the most cost-efficient manner? How do we optimize the capacity? How do we optimize the processing of your massive pipelines? The third dimension of data observability is actually real-time insights of all the personas. In other words, all the users who are essentially the producer or the consumer of the data. When we talk about the producers of the data, these are the systems who are generating the data, delivering data to our platforms. Your data engineers who are actually now writing all this complex data pipelines to create the new KPIs, business KPIs, technical KPIs, all your platform engineers who are constantly looking at the health of the platform, who are looking at the heuristics of the platform, is the platform uptime, SLA, scale, performance, as well as your business executives and your executives, data analysts who are actually looking at the value of those KPIs to make business decisions. I think one of the most important pillar of the data observability in the end is about reliability of your data. How clean is your data? How trustworthy is your data? What is the fidelity of your data? Is your data coming from source, the same data you are writing on your destination? Is your data, are you seeing a gap between your data from inputs to outputs? Are you seeing a schema drift or a data drift? So I think, why do we think it is important? In a nutshell, data observability is essentially maximizing your data reliability. It is helping you eliminate your operational blind spots and reduce your spend across the data stack. I will actually share a couple of really good examples. I was recently having a chat with Rohit Chaudhary, who's the CEO of Excel Data. And then we were talking about the value of data. We were talking about where the data is going, where the organizations are going, what are some of the challenges. And he gave a really easy and a great example of the data drift. Let's say an organization is creating some new machine learning model to do a classification model to send a new marketing campaigns to your customers. And your customer base is 50% of customer base is male and 50% of customer base is female. So pretty straightforward model, as you can imagine. And then the data you are getting from different sources, the data change automatically. And there was no way for you to identify what has changed. All of a sudden, your male population demographics went from 50% to 35%, and your female population demographic went up the same scale. And your model ended up wasting additional amount of money, and it actually decreased your campaign effectiveness. So that is one example of why it is very important for you to understand the data drift, to understand actually what has happened, why did it happen, what is the impact, and what will be the next thing. I have been privileged to work with many different teams across the enterprises, and I'll give you another couple of examples where I think the data observability is now kind of becoming the mainstream of all the data teams. It should be part of what I call as the DNAs of our data teams. We have summer coming up, and imagine a family going on a hiking trip to Mount Yosemite or Mount Rainier National Park over here in Seattle area. One of the person in the family, unfortunately, get lost in the woods. And then the agencies will reach out to telcos like T-Mobile. We will use the triangulation data coming from our devices to identify where this missing person might be. What if the location you're getting from data and the rules you've applied in your data is actually showing this person who is missing is actually 100 miles away from where the actual location is? Imagine a scenario where a small data quality or an anomaly in your data pipeline is actually potentially impacting a life of a person. The other example I would love to give you is we spend tremendous amounts of money every year to expand our coverage and a customer experience. We are building a prediction model to eventually come up with a best solution on where should we invest our money in terms of new capacity. Imagine your prediction model actually has a data quality rule issue applied, and then the coverage impact, which was supposed to boost the coverage of our customers by 20%, is actually negatively impacted our coverage of customers by 5%. As a carrier, that's the last thing I would like to do. I would always want to have the best customer experience for our customers. This will add more cost to my care, more dissatisfaction of my customers, and maybe potentially a churn. So having said that, this is why, as I said earlier, data observability is extremely important and critical to identify what has actually happened. In this case, X number of customers coverage got impacted. It is now helping us identify why did it happen. Again, why is where we applied a bad rule or a transformation or a model which actually had a bad precision and accuracy, resulted in a bad decision. What is the impact? It can potentially impact churn. What will happen next? If we don't fix that problem now, it will continue to have a detrimental effect on customer experience. Okay, having said that, I'll talk about how did we implement data observability in our hybrid data estate over the last many years. From the 2015, when we started our data warehousing to Hadoop journey, to a cloud journey, a big part of our platform observability was coming out of our on-prem platform running on Hortonworks. So we were leveraging traditional services like Ambari, which itself was not giving us the good understanding of where we have challenges the platform. We ended up bringing up a really awesome, cool APM tool called Paper Data, which actually gives you some heuristics about your platform, always looking at your yarn queues, and also looking at ways to optimize by doing capacity optimization. With the Azure from 2019 onwards, we started leveraging for spend analysis. We started leveraging Azure Cost Management APIs, build a kind of in-house Power BI reporting tool on the top of it to identify where we're spending, how much we're spending, and what services we are spending the most. And then we ended up building an in-house data reliability tool to capture the end-to-end data pipelines all the way from data coming from source into Hadoop to doing insights on cloud. It worked really, really well for a period of time, but as the complexity increased, as the use cases increased, as we started doing a lot more advanced analytics, as we started doing a lot more real-time analytics, I think we needed to have a little bit of a more modern tool, which helps us identify and fix those gaps. And this is essentially where we started early 2022, a small POC with Excel data. The initial scope of the POC was essentially looking at our platform observability of our Hadoop platform. At that time, we were running around 300 million plus small files on our Hadoop cluster every single day. And people who have a technical background in Hadoop will understand if you're running a single platform with 250 million plus files, you're going to always have a name node as your chalking point. This was actually really giving us lots and lots of pain points to us. This was really making our life like hell. Every single day, we were kind of doing reactive measures to go and clean files. We were kind of running extra process at the end of the day to the concatenation of the small files into bigger files. We have to kind of slow down some of our new development tasks to constantly do the cleanups. We were doing a lot of manual outbuilding, a lot of manual work to essentially keep the health of the platform intact and not have detrimental impact on the overall platform. At the same time, we were running into around 60 petabyte of storage on our cluster. And that is not easy to manage in a single platform, running on a 2000 plus node Hadoop cluster. With the and we have around hundreds of power users, developers, and other people who were constantly running production workloads. We were running some ad hoc analysis, experimentation, all kind of fun stuff on our cluster. That's not an easy thing to do. This is where we started with the POC on Excel data. And then we saw some great early results, which I'll talk about in the next step. With that, we kind of working closely with the Pepper data. We also asked them to help us kind of identify some of our spend analysis on our Databricks platform. This is where we are looking at a single pane of view of looking at cost of all the Databricks workspaces, all the users, all the long-running queries, all different kind of compute, all in a single pane of view to look at where are we overspending, what's the underspending, our opportunities. And we continue to leverage our on-prem in-house based data reliability tool. As we implemented Excel data on our on-prem platform, as well as on our Databricks, in the less than a year, we have seen some tremendous benefits and value realization from this platform. We were able to clean up a large volume of unneeded, unwanted files. We were able to actually surprisingly clean up 8 petabyte of unused data, the data which was sitting on the cluster but was not used for more than 15 to 18 months. That visibility we found from the tool, we went back to our end users, and then we were able to kind of clean up that data. That almost gave us 2x increase in platform performance. We found some opportunities where we could do the yarn tuning, we could make the changes on our platform, we could do optimization on our Spark jobs, which saw 2x increase in our platform performance. Our end users who were always very dissatisfied running across all the different time zones in US, that, hey, we are kind of blocking their innovation or decreasing their productivity as they could not do most of the things when our production loads were running. That heavily increased the user satisfaction. With the 8 petabyte of cleanup of our data on our platform, it helps us significant cost savings. We reduce the need to spend additional capacity boost on our on-prem platform. And in a nutshell, we were able to proactively resolve many issues, vulnerabilities, security patches, a lot of things which we could not able to do through traditional Hortonworks, Hadoop, Ambari services in a very short amount of time. In a less than a year, we have seen great value, and we are not done yet. We are now essentially looking more and more into our data reliability with a lot more stuff we are doing on our AI journey in the last 2 years. And as I spoke about the importance of accuracy of data, trustworthiness of data, fidelity of data. We are now working on integrating our data reliability solution for Hadoop and Databricks with Excel data, and also implement data reliability for Snowflake, which we have recently launched, as well as also implementing spend analysis and compute analysis for our Snowflake implementation. With that, I will conclude my session for today. Thank you so much, everyone, for joining the session today. If you guys have any questions, feel free to reach out to me offline. I'm sharing my LinkedIn profile here. Again, thanks, everyone, and have a good day. Bye now.